First thing, ask questions when y'all have questions. Okay? If you don't understand assignments, ask questions in class in y'all's case, or via email, or catch me in the office, in person, or on telephone. So I do answer questions. I answer all email. Because if you've sent me an email at this point, and I believe all of you had to for your introduction anyway, if I remember right, you should know that you get a response from me promptly. If it's during the business day, that you get it back that day from me, unless I have told y'all I'm out that day. And if I'm not going to be available on a certain day, I have sent y'all notices and told all the classes that I probably won't be answering during that day because I'm in a meeting or whatever. Next Thursday, Friday, and the following week will be an example of that, because I'll be in school meetings all day on Thursday and Friday in Calhoun. And then that next week, starting with Sunday, that I will be in North Carolina, because on that Sunday I will be driving to North Carolina, to northeastern North Carolina, so probably like an 8-hour drive. I haven't calculated it out exactly yet. And then I'll be in meetings all day, each day, and sometimes in the evening, because I know, pretty sure there's at least one supper event for us there, and the other one is more than likely I'll at least go to supper with some others one other evening, and if I go out to eat with them, that's going to take several hours usually. And I may be meeting with their people that organize the conference, because I'll be meeting with them at different times also. Besides attending the conference, I am seeing how to set up the same conference in Georgia in a year. But each day I will answer email every day during that week still. That when I get back to the motel each night, I will get online and answer emails, unless there's a technical glitch. As always, when you're going to use motel internet, there's a chance that I may not be able to get on or whatever. And then I say, depending on how things go, etc. on it. But they could be rather full days for me. The days could run from 8 in the morning till 9 at night or something on it. And I'm sure at least one of the days will run like that. So we've got that all in there. But I am continuously, and this morning I got hit with it pretty strongly, of some students in two other classes, not in y'all's class, not in this class, of students submitting things to me that were due last night, and either one putting in the assignment that, and you're in 1305, who else? Are you in 1305? Okay. Are you in 13? So you're the only one in 1305. Putting in their assignment in 1305, and it wasn't your class, it was the online class. So don't think it's him. Putting in the assignment and saying they couldn't get it to work and that they rigged around to do modules to work. What did I tell y'all in class, Isaiah, on modules in logarithm? They don't work. There's a note out there in Blackboard that says the same thing. It will not run because logarithm's not designed for it. And to just do them, and then we paper test them. And then that assignment, I actually told the students, submit it, And that one I was going to review it, return it to them of what problems they had, and then for them to resubmit, and I would grade at that point. And I get these comments from them of, didn't know how to do it, or I rigged it to get it to work on it, which meant they took out modules on it, which is what the chapter was about. Or I didn't understand how to do it, and that's the first I heard from them. Or one wrote me and said, I couldn't do it. Didn't understand the assignment. So I failed the homework for this week. Could you send an example? Actually 2 examples I put out there in Blackboard for them of how it worked, besides discussing those examples in the lectures that I post out there. Which inclines me to believe that they've done 2 things. They didn't read what's in the assignment to them, and 2, they didn't listen to the lectures I posted out there. Because you heard him, that it won't work. And I've had it pop up in other classes. So if you've been on Blackboard in the last few minutes, or been in your email in the last few minutes, you see there's an announcement /email telling you all that same stuff again. And I'm probably going to cut out this first part of this into a separate lecture, leave it in this one, plus put it in a separate one posted in all the classes with that bit I just said. So that it's also in audio, that it's not just them having to read, but they can listen, they can read. So I really have questions on that sometimes. And I have told y'all, both in class, and I have told everyone in messages, announcements out there already prior, ask questions. I'm not sure what the exact problem is. One, I'm suspecting that it's one that y'all aren't getting answers from other instructors, or they're not encouraged, they're discouraging to ask questions, and so y'all think you shouldn't ask questions. Every instructor should be responding to your questions. May not give you all the information you want on it, because you may be asking them to give you the answer, and they're not going to give you that. They're going to help you in understanding the problem and how to do the problem. But they should, every time you write an instructor here, you should get a response within 3 business days. Okay? So that means if you send me an email today, college and state policy requires me to answer within 3 business days, which means today's Tuesday, so I've got to answer you by Friday. College policy says also that it's preferred that we answer within 1 business day. Of course, that means if you write tomorrow on Wednesday, it could be Monday before you heard anything. And that's way too long. Okay? I have pushed it to people I have that come up more or less under me, although exactly how the organization chart is in this place, I'm not sure. Everybody may report to me and may not know it, in which case I'm not telling everybody. Nobody may report to me, but there's some people I think report to me that I've told them they should be answering back within a business day, unless they have told students there's some other situation on it or something about it. Because if you're an online student and you got a question, you need an answer pretty promptly, or else you're going to sit there going, what's going, and losing time on it. The other part is when you have problems, write and ask me questions, or write and ask your instructor questions. If an instructor is not responding to you, then you need to alert the dean about that. Because that's what we're being paid to do. We're being paid to teach y'all. we're not just here just to grade your papers. You're paying, and whether you're on financial aid or not, which most of you are, 95% of our students or something get financial aid. You're still paid, even if you're on financial aid. You're still paying that amount. That's money that was given to you to give to the school. It's going directly to the school, but it's passing through you, and that you're paying it. And if it's on government grants, etc., if you're not paying taxes now, you will pay taxes, which is paying for that. So you're paying on it in any event. That you're paying us, and that you should be getting something more from it than just a course sitting out there and nothing hearing back from it. That's what y'all are paying for. I'm taking free classes from Hillsdale College, online classes. They don't have a way for, actually the president of the college teaches some of them, and he actually says write him and ask him and tell him stuff. How well he responds back, I'm not sure, because I haven't ever written him anything about it, because it's factual stuff I'm learning, and it's just things I'm learning, and I'm not getting graded on it either. Basically online classes, non-credit. But I have written him one time, and he wrote me back within 2 hours, which I was rather impressed with when I got that back from the president of the college, that has just got a recorded thing out there that 1 million people are watching or something, and that he's still answered very promptly on it. And it was actually where I'd hit a technical glitch in their course. It was actually giving certificates too quick. They changed their system, and if you clicked in there to register in the class, then you went in the class and you could print out your certificate of completion right then without ever having gone in the class. That's not quite correct, because actually the way they've had it, and they've got it fixed back again, is that you have to make an 80 on the final for the class, and then they actually, and it's not just print out a certificate, you can print it out, but they mail you a certificate for it, which is rather nifty for a free class. Now, those are not computer classes. They're more political oriented classes. Most of them are about the American government, but there has been one on education for K through 12, and a couple of economics and a couple of literature classes. I guess about 4 literature classes. So they've been interesting to me. And I've done about 8 or 9 of the 13 they got available so far. So, and I have taken credit online classes from Georgia Southwestern. So I know what it's like to be on y'all's side of the shoes in an online class. Also taken some classes from CIST that way. And the importance of getting responses and stuff. And in that case of the Georgia Southwestern classes, 2 out of the 3 classes I took, the instructors were liable to take 2 weeks to write me back. And I was sitting there going, I had a problem trying to do the assignment, and I couldn't get any help. By the time they wrote back, I was going, I don't know. I may have figured it out by then, or B, I got to go back and figure out what was the question, and C, figure out whether or not they actually answered the question I had at that point. So that's why I try to answer back real quickly. And I realize some instructors can't answer, that a lot of the instructors can't answer back like I can, but still they should be answering back during their workday, because we're all working 8 hours a day. Adjuncts, I realize is less, but they've got less classes on it, and that there's limited times when they can, but they should have. And when I taught adjunct for Pierce College in Philadelphia, that those students knew that I would be answering back to them in the evening, and that I'd only be available in the evening to answer them. So adjuncts are the same way as full-time. It's just they're a little more limited, but they got less classes than a full-time person. And then I'm probably in the top 5 in the number of classes, maybe in the top 1 or 2 of the whole school of 200 instructors. All right, questions? All right. Was there questions on the lab on chapter 4? Somebody said yesterday in one of the classes to me that there was a problem with it or something. Is there or not?
Work fine.
Hmm?
The packet tracer?
The packet tracer.
Work fine.
Was any one of you needing me to go over that one? Somebody said something to me during the day yesterday on it.
I said something about a wire, not being able to get it out, but you messaged me
You got it?
back. Yeah.
Okay.
The only question I had is they said to connect, I think it was 2 routers with the serial cable.
Mm-hmm.
And I think I can't remember which one I used. Does it matter which one you use? There's a DC and a DTE.
All right. You're going to have to use on it, actually, since y'all are doing a connection between the routers, either one of them work in the middle and get my wires. And lock the door.
I mean, what I used worked, but I didn't try the other one. I thought, I wonder if I, they didn't really tell you which one. You said serial cable. Oh, really? Okay, so mine works, I guess you're
I
right.
think it was the DTE.
I can't even remember, I just grabbed one that doesn't go green.
Nope. I don't have a serial cable here. But with it, what the DCE, DTE is, when you leave the router and you're going to the other router, in y'all's cases, we're doing straight router to router. So it's really just a straight serial across, but in the middle of it, it's actually 2 cables that plug together. Okay? One of them is going to be DTE and one of them is DCE. It's data terminal equipment and data communications equipment. The question is what the difference between the 2 of them is going from the router, is it connecting out to data communications? Okay? That if it is, it's using the DCE. If it's the terminal equipment is using DTE, and the 2 actually connect together, and that allows you to go through using the telephone company as your cloud. So when you're going out to the cloud, you're going from DCE, going from the piece of the router, connecting to the cloud, and then connecting from the other end of the cloud and actual out. In y'all's case, you're connecting straight through, so it's got DCE and DTE on both. That you're using actually the 2 cables together. Okay?
I just grabbed one off the packet tracer and
So-
it turned green, so I figured it must be the right.
As long as it's connecting across, but if it was connecting to actually the telephone equipment out there to their modem, connects out there to them, connecting from that at the other end, then you got to have on one end that you use the DCE and one end that's got the DTE to connect to and from the telephone equipment.
I mean, is router to router, is a serial cable common, or? I mean, I'm not-
Yes.
Is it quicker or something?
Well, that's how you're connecting from the router to your other router, is through that serial connection. Okay? And that's going to be faster than your Ethernet one. Okay? So you're going to connect router to router always on serial connection across it. Now, and it's got, they were big cables, and I'll try to remember when I'm over at Walker next time to bring back serial cables, because I need to bring a couple of those over here anyway. And then y'all can see, their old ones were really big, bulky, and had a big connector on them. Now they've just got a small connector on them. Just two white ones. But on the back of the router here, there's two little white connectors, which are your serial connectors. There's two of them because you're going to be plugged so that you can plug two other routers on. And you can add more in the other spot on here. That's going to give you two, allow you to go out to two places.
It's funny that serial's fast. I remember when printers first came out, serial was real slow.
Mhm.
Remember the Centronics parallel dealer, it was so much quicker because you could flap over 8 bits at a time.
But-
instead of just one.
Think about
And across
this,
top
you've
and
actually
higher.
gone to serial back on printers. Because what are y'all using for your connection for your printer now?
USB.
USB. What is USB?
That's serial.
Serial. The S is serial.
guess
Okay,
it-
second thing, hard drives. They had parallel interfaces on them, and now we've gone to serial on them because we've gone from PATA hard drives to SATA hard drives, and the difference between them is parallel to serial. Because you can actually pump it across faster on serial, but the nice part on parallel was you were pumping 8 signals across at a time. So you were pumping the whole byte across.
I guess as the speeds got higher, they get.
As the speed got up, that went out the window. All right, other questions? So the serial one, normally on the serial one, it's the lightning bolt blue, I believe, light blue, I think it is. Does that sound right in packet tracer? But it's a lightning bolt.
I know blue's console and the.
Light blue is console, but there is,
Like dark blue. It's a dark blue.
dark blue? Okay, I was thinking it was blue, but it's got a lightning bolt.
Yeah.
Serial's normally shown across there as a lightning bolt. It looks like a lightning bolt. It's really not a lightning bolt, but that's the way it's drawn. And if you talk to anybody that does stuff with it, they're going to tell you it's a lightning bolt. Everybody knows what that line is. Right? Other questions? Any other questions on that one? All right. So we're on chapter 5 now, right? All right, it's looking at, it's got it labeled as Ethernet, which is basically where it's at. So we're talking about MAC addresses in the chapter. We'll get to IP addresses in the next chapters. But in this one we're looking at MAC addresses, so we're really still on the data link layer. So we've actually ended up with 2 chapters on it, but they split it out. Because the Ethernet, they split it out as a separate one. And that Ethernet's working on the bottom 2 layers. And they talk about the sub-layers again to you, the LLC and the MAC. And we've already talked about those and about what's going on there. and what's going on with those. And then they talk about the frame again, but now instead of just the frame in general, they talk specifically the Ethernet frame, and they give you what the frame structure is for the Ethernet frame. And now we see some of the things that fall within the frame. That the number of bytes that's in each of those, I wouldn't get hung up on trying to remember those. I couldn't tell you how many bytes is in each of the different fields within the frame. Okay? The total size on it, which should be 1510, I think. That one could be something that I've never really had to do. I've never had anything, real things pop up. I might have had some questions pop up a time or two, but it was just a question or whatever, and I just didn't worry about it on some of it. There's a couple of sizes there you do need to be aware of. So on the frame, the first thing on it is a preamble. Preamble is basically going to tell you that it's going to have a starter frame, so it's got a 1 byte field that's being used there that says here comes the frame, basically. It's sort of like the engine on it, okay, on a train. It's just the start of the whole thing, okay? It's also, when it's timing them going across, that's where its timing mechanism's on that one going. But that's going to be just a marker to mark the beginning of it.
That's what I have a question on right there.
Okay.
That on the online, I got it pulled up too. Online, they got like a little thing where you pull stuff over and all that. And so they say that the preamble is like 7 bytes, and then there's the starter frame delimiter as part of the preamble.
Correct.
And so part of it is the sync. So they're saying, hey, let's get synchronized, and then part of it says, okay, here comes the frame. Right? So and the way I read it, I understand that the preamble is the part that the first 7 bytes or whatever is the part that synchronizes it, and then that starter frame 1 byte says, here comes the frame, but in their little thing where you drag stuff over, they got it the other way around. So I wasn't sure, so I Googled it. Of course, Wikipedia, who knows if it's right or wrong, says that the preamble part is what synchronizes it.
It synchronizes on the preamble, and it's using the whole thing to be signal to it. Here's the start, so it's got that many bytes there of the total of 6 bytes to get itself realizing there's going to be the start of the frame right after that. Of
We'll
where
look at this and see if, I mean, it just doesn't seem like this is right though. All right, so this is what they're saying is correct. Preamble notifies destination to get ready for a new frame, and then start a frame, they do all this jumping here, review and evaluate incoming cybersecurity information. But synchronizes sending and receiving device to frame delivery. I would think it'd be the other way around, but I don't know. I would think the starter frame would notify you ready for a new frame, that the preamble is synchronize the sending and receiving.
I can see what you're saying, but I think they've got it like they want it there. Because the starter frame, because a preamble is just the marker that is coming, so that's the headlight on the whole thing. And then the starter frame, it can have some stuff in there, but it's going to be letting it know to synchronize with the other device. There's actually a frame involved.
That same reason. I just wasn't sure about that. And then when I Googled it, whatever.
And they're not always real clear on that, but the preamble is doing all of that stuff.
Yeah, I knew the preamble did all that stuff.
And they've sort of split it on out, but usually it's not split on out on that. But there is a byte to mark it to start, and then the whole section of it's there to get it going. So it's, in a way, because the preamble itself is sort of looking like an engine on a train, okay? You know the train's coming because you see that engine. The headlight's really that first little piece. Then behind that is going to be the destination address and the source address. Destination comes first, source comes second on the frame. And that's intentional on there because depending on how we're working with the frames on the routers, we can actually have them look at the start of the frame and determine where to send it and start transferring it on out the other port as it's coming on in. And we'll see that on some forwarding methods. Or we can sit there and get the whole frame and then decide where do we forward it to. But we can actually, once we get the destination address, start forwarding it out the other place as it's coming in. So you can keep the train moving right on through instead of it having to stop and start back up again. Obviously reduces latency if we do that other. However, it can have some limiting parts on that. So you'll have the destination address, which is a MAC address at this point, so it's 6 bytes long. And I talked about that the other day on the MAC addresses. The first 3 bytes is what?
Manufacturer.
The manufacturer, and the last 3 bytes is a serial number, basically. Okay? And that's the next device it's going to. Everybody follow on that part? It's not the ultimate, until it gets down to the end, it's not the ultimate destination. Source address follows that, and that's where did it just come from. So on MAC addresses, it's just telling us the immediate part of where it's coming from and going to. That's 6 bytes, obviously, also. And then it has ether type field, which is going to tell us is this an IP version 6 or an IP version 4 or an ARP or whatever type of messages are being sent across, although the IP stuff really falls into the data on it. Then the data will be there. That can be variable size. As they note there, it can be from 46 to 1500 bytes long. Okay? So the amount of data in there will vary. It's not going to be the full amount always. Following that, but it's going to have in there, it's got to fall on a full, on the size lines on it. So it will in turn, so a frame's got to be at least 64 bytes long, and it could be up to 1510, I'm really thinking, but maybe I'm wrong. No, that's not wrong. 12, 1518, okay. But it's going to be over 1500, so it's going to be in the 1500s. And the only time I've ever seen it on a test, the only answer that was going to be right for me was there was one in the 1500s and the others had all kinds of strange numbers. And so I didn't have to worry about the exact number. And then again, like I said, that's not a heavy concentration on their part anyway. So when I've took the class and took the test on it, or when I've taken certification tests, it didn't make any difference on what the outcome was to me. That it was just a question or something on it overall. Following it on the end is a frame check sequence field, which is used to determine whether the entire frame is there. That's going to use a cyclic redundancy check, or CRC. And what that tells us is for it to be able to determine if errors have occurred in the frame and transmission. So it's going to create this number and put it on there from the actual data. And basically it sits there and adds up all the bits and then chops it off and just puts a number from that on there. So it's not putting a whole big number of how many bits were turned on in it, but actually it's just in terms of an odd even type thing, or actually it's a little bit fancier than that. Puts that there, and if it still matches at the other end, it's going, this is basically all received intact. Because if a bit got messed up, because it does it on a number of them, of what it does on, but it doesn't do of the total number of them. But if one bit got lost in the process, it's going to throw the whole number off. And so then it's going to have, when it recalculates on the receiving end, it's going to go, that doesn't match the number that the sending end put on it. And so it's going to go, there's an error in here somewhere, something happened to it. Okay? It's not going to catch them all, but it's going to catch most of your errors. And if you're having errors occurring out there. Now, those of you that have seen dial-up, how many of you used dial-up or watched dial-up before? A couple of you. If you remember on dial-up, when you watched down there where now we got the network activity, that we had the dial-up activity down there, that sometimes you would get a red mark down there on it. What it was telling you was the CRC was not coming through correctly on the bytes coming across, on the frames coming across, and that it was having to request those be resent because they were getting damaged in transmission. And it was actually telling you by the red little symbol on the dial-up that there was CRC errors occurring on there, which with dial-up occurred quite often, particularly depending on how much your phone lines are being used at that point when you were trying to connect in, and how good of quality of phone lines you had that you were traveling across, etc. So CRC popped up regularly on those. With the digital approach instead on it, we don't have that big of a problem with it, so you don't very often see CRC errors on it. That the MAC addresses, and they keep wanting to put Ethernet in front of it, and I'm not used to that approach on it. But MAC addresses are in hexadecimal. Okay? I'm going to give you just a brief little introduction to hex right here. But when we get in the next chapter and we talk about binary, I'll teach you real hex at that point. But just so you're aware of what hex is. And we get into either the next chapter or the following chapter, one of the next 6 or 7 or 8, somewhere in there. 6 or 7 is where it should be. We're going to actually look at complete conversions and sit there and convert all kinds of numbers. But for MAC addresses, you're not really needing to worry about that. When you get IP addresses, we're going to do all kinds of stuff with them. The MAC ones, you're really not doing stuff with them other than you need to be aware of that it is hex characters. Decimal. I'm going to go ahead and throw you some of this right here. Decimal number system. How many single-digit characters have we got?
0 through 9.
So there's 10 of them, right? So it's a base 10 number system. Okay? And you've got 0 through 9. And when we get bigger than that, we go to the next column. Okay? Hexadecimal is a base 16 number system. These are 16 single-digit numbers in it. How many single-digit numbers do y'all know? 10. 0 through 9. But this has got 16. Okay? What you're going to use is you're going to use letters for the next ones. And this is standard math. If you go to higher number systems, they go to using letters, and then if it's something bigger than a base 36 number system, they go to Greek characters. And then what they do after that, I'm not sure. I just learned that somewhere along the way, but I couldn't be beyond, I guess, alpha, beta. I can do A and B in Greek, but beyond that, I couldn't tell you what they are. Okay? So you're going to have 0 through 9 and A through F. Okay? A is going to be equivalent to a 10 in decimal, and 11 to B, and so on down to 15 is equivalent to F. Okay? But in the hexadecimal number system, you've got 16 single-digit numbers. Okay? The computer is going to work in what?
Binary.
Binary. Why is it going to use binary?
All it knows is on or off.
Because it gives it an on or off situation. Because it's easy enough if we just look at stuff on the computer as either on or off. Because from an electronic viewpoint, either the electricity's there or it's not there. Or if you're writing it on the disk, is there a magnetic spot there or not there? Or if we're writing it on CD, what are we doing there?
Pits. Other pits.
You got pits if you burned a hole in it, and you got lands if you didn't burn a hole in it. Okay? So there's either a hole or not a hole. That's real easy for machines to recognize, as opposed to if we tried to do the machine in decimal, trying to figure out the difference between a 1 and a 10, a 1 and an 8 would get difficult. Light switches. It's real easy for John to tell me to put this light switch in one or the other position, but if we had one of those adjustable ones, if he wanted the lights on a specific amount, trying to tell me to get it to that specific amount is difficult, right? So likewise on the computer, it's going to be the same as a light switch. It's a whole lot easier to tell somebody to turn a switch on or off than to turn it on 40% of the way on the variable ones. Y'all all used variable ones at some point. There were dial ones, and then everybody disagrees on how much did we turn it on. Even on where I've got variable control on the sanctuary church for lighting, I can turn theirs on variables. The slide switch is still a certain amount of guess of how much between 4 and 5 or right around 8 is exactly the amount to put it. When it was on and off, it was a whole lot easier that everybody agreed on. As it is, there was only a handful of us at the church know that it's a variable control on it, and that I've got more control than just halfway on and off. So, the computer's going to think in binary. We're going to think in decimal. Why do we think in decimal?
What we've been taught.
That's true, but why have humans generally used decimal as their number system? When people started learning to do numbers originally, way back, way somewhere in time, why did we go to decimal as the normal rule?
Did we actually read higher than
No. Why did we come up with 10 single-digit numbers? 10 fingers. Very good. Someone's awake up here. So we're using decimal because of that. Because when people originally started counting stuff, that Savannah and I were going to trade some stuff back and forth, and we wanted to figure out on it, and we didn't have much communication at that point. We could at least use fingers to represent how many of whatever it is we were trading, right? So going to a decimal number system made sense for humans because we use 10 fingers, and if we ran out of fingers, where do we go to next? We can go to toes. There's 10 more of them, so that works nicely. Or we could make a marker on the ground when we ran out of 10 fingers, and that was when we went to our next column. Okay, that every time we ran out of fingers, we made another mark on the ground. Now, not all humans have used decimal. The Babylonians, which is Iran now, okay, which was an advanced civilization back there around 1000, 2000 BC, somewhere around 1000 BC or whatever. 1000 to 2000 BC, that they actually used the base 60 number system. They had 60 different single-digit characters. Okay? You have to live today with what they did, because they were very advanced, and we still use things that they came up with. How many seconds are in a minute? 60. How many minutes are in an hour?
59 or 60.
60. How many degrees are in a circle? 360. Okay? Notice something about all those numbers? They come off of 60. Okay? That's because the Babylonians came up with those. Okay? When they were using their base 60 number system. And they had 60 different single-digit numbers. My understanding of it, and I haven't done a whole lot of study on it, is that they came up with that was that they were using their knuckles to all come up with it and came up with 60 different positions marking off the knuckles and positions on their fingers. That's how they came up with 60 somehow. Not exactly sure how that works.
I don't know either.
But it did, okay? It's from something I read on it. But it didn't go into depth into when I was reading on it. But that was, we've gone for a number of years. Why in the world did they do 60? That's what my understanding is from something I read just a year or two ago. That it was actually working off of knuckles on the fingers to somehow come about with that approach to it. So, humans have not always used decimal, but most humans have used decimal. But the Babylonians actually, besides coming up with all of those things we just mentioned, they also back there at that time period, by using shadows into a whale and stuff, had figured out what the circumference of the world was to within a certain number of feet of what the actual circumference of the world is. So they were real advanced, mathematically accepted on it. That part's just thrown there for your information. But us decimal machines, binary, and hexadecimal, when we look further at it, we're going to see that that's really used as a way for us to easier look at what's inside the computer and see actually what's exactly there. But it's not putting the decimal because then stuff can get confused on it. This will actually show us binary representation of it without looking at a ton of zeros and ones. Because with hexadecimal, we can take 8 bits and represent it as 2 hexadecimal characters. Okay? So we can, and what does 8 bits make? A byte. Okay? And we said in 1 byte you can store what? Word. 1 character. Okay? So letter A will take 1 byte. Number 1 normally will take 1 byte. That can be a little bit different, but normally you can think of a byte as the space to store 1 character that you know of. Okay? So if we want to look at exactly what is stored in the computer, we could dump it out literally like it's out of the computer, do a memory dump and see exactly what's there, or look at exactly what's on the disk in binary. I got a question for you. If you looked at a whole page of zeros and ones, and you needed to know what the 150th one of them was, it's going to drive you a little crazy, isn't it? You have to try and find that down in there when all you're looking at zeros and ones. Look at some of the things you get sent across Facebook where they say find the C in the whole grid of zeros. Imagine it just being zeros and ones trying to find a specific position on it. Is it a 0 or a 1? Okay? You go crazy. Just like you can go crazy looking at that little chart that everybody keeps passing around on Facebook that has all the zeros, but there's a C in the middle of it, and can you find the C? The C's and zeros look pretty close together, and when you're looking at a ton of zeros, suddenly the C becomes a 0 too. Okay? Hex will allow us to have gotten it down in groups of 4, and then we can just find the correct one and split it apart to find a specific spot. And we're looking at 16 different characters there instead of just 2, so it's a whole lot easier to see, but we can still see exactly what's in the machine. So hex is what we're going to get the machine to dump it out in a lot of times. And so your address is presented to you in hex, your MAC address, but it's really a binary address. Does everybody follow on that? IP addresses, we're going to discover, they're really binary again. They're going to be 4 bytes long instead of 6 bytes long. An IP version 4 address. And it will be presented in decimal for us. And that's where you normally see those. MAC addresses, again with the MAC address, that tells you every specific device in the world, but the only relationship between them is who manufactured. But it's got a specific address burned in at time of manufacture. Does that make a little sense to y'all right now? Just about what hex is. We're going to go more into it in the next chapters. I'm going to spend a whole day talking about number systems one day. Okay? And so you've just gotten a piece of it today. But if I don't tell you a little bit more like I just did right there, it makes a little more sense to you. And then throwing in the base 61 just for fun for you. So they go through and they tell you on that conversions. We're not going to worry about that till we get to the next one. That hex decimal is going to be used to represent IP version 4 addresses. Hex is going to be used to represent MAC addresses and IP version 6 addresses. So we're going to see hex actually appear for a second thing later on. So then they go through and they talk about how it goes through. And like a note, what it does is when it's received, it gets the frame, looks at the destination address, and sees does it belong where it is, or is that a MAC address that is on the network attached to it. Okay? If it's not, it sends it out the appropriate address, and it's got a MAC address table in there that it then decides where to send it on to. They talk about unicast and broadcast and multicast MAC addresses. Unicast addresses says we're sending it to one other machine. It's getting sent to a specific machine. That's what a lot of the stuff you're sending out is doing. And like when y'all go to get a web page, you're doing a unicast type thing. You're making a request from a specific machine. Broadcast says that this frame is being sent to every machine on that network. And actually could be a broadcast. Used to be that it would be a broadcast out to everybody in the world. The firewalls stopped that one now. But if you go back 2000 or before, if you put a broadcast out there with a MAC address, everybody got it. Okay? Unfortunately, people that have used systems and stuff figured that one out and started popping up all kinds of stuff on everybody's machine. All over the world. Okay? So broadcasts are just going to be within your network or within your subnet. But it goes to every machine. Now, people will sometimes send out broadcasts, not often. But machines do broadcast all the time. Because when John's machine comes on, it sends out a broadcast saying, I need an address to get its IP address. It makes a broadcast out there because it has no idea where the server is that keeps addresses for it. Does everybody follow on that? Because it doesn't know anything about the network at that point. So it makes a broadcast that says, I need an address. At different times, each of your machines is also sending out a broadcast saying, I'm so-and-so, I'm here. For everybody else to know it's there. It's not something you as a user ever see on there, but it's going on in the background all the time. And then the other machines are doing the same thing, and each one of them adds it to its own MAC table and goes, okay, I know these are the machines that are attached to me, that we're all attached together. So it's like you walk into class and you announce who you are. And think about it, sometimes there are some places you do that, where you get on a WebEx phone call or whatever. What do they have you do when you first connect through on it? To tell everybody else that you're there. It tells you to state your name, which goes out to everybody on there, and they all hear you at that point and know you're now present. You just unbroadcast. Multicast is when it's sending it out to a select group of devices. Now, when we get IP addresses, we're going to see the same three things occur there. With multicast, it's going to just certain devices on the network, not all of them, but more than one device. Big thing that uses multicasting is video streaming, as it does it on a multicast approach. And then they note there that's used for gaming also. And video conferencing could use the same approach, and that way it's not separate, because if it did unicast, you'd have the same thing being sent out a ton of times to get to all the different machines it connects to. You don't want broadcast because not everybody's wanting it, okay? So with multicast, it can use a multicast address set which says it belongs to certain machines that are listening for that multicast address.
That wouldn't apply like sending an email to 4 different people or something, would it? I mean, this is just like for your local area network. That doesn't really apply.
Sorta, it's the same type principle, but it's not on that, okay? Because actually in that case it is sending it, each of them is getting a separate copy of the message. Texting though, you are doing multicast when you do multiple recipients on it. And that when you send that one across, it's actually doing it as a multicast one to all of those recipients.
Yeah, because it asks you, do you want to send this as individual or not? So I guess you have a choice.
And so it's giving you a choice on some of your phone systems. It's giving you a choice of whether it's going to unicast it to each one of them, or is it going to boom it all to all of them. And I wish my phone did that choice on it, but it doesn't. But because if you get one that went out as a multicast text on that, if you hit reply on it and it came in as the multicast one to you, your reply automatically goes back to all of them that it came to you on. And every time when somebody does send you one on that and you hit reply back and you put a message, there's always someone on there that doesn't realize it went to a number of people and write back and go, who are you?
Yeah.
And you're going, I was responding to so-and-so's message. That they suddenly don't put it together on it. Because every time I get one of those and I reply back, I try to, unless it's where I know it's just a small little group of 3 of us or whatever, because my brothers and sister and I were texting, sending that my brother had sent us a group text like that this weekend, and I knew all 4 of us knew what we were talking back and forth on. It wasn't any problem, and for us all to see what the other said. But in other cases, I try to normally make sure I'm just replying to the one person, unless I really want everybody to see my reply. Because a lot of times on it, you don't want the others to actually see your reply. Because John sends out a request saying that he needs $1,000 to get out of jail. I might not want everybody else to know that I just wrote him and told that I'm writing and telling him I'll give him $25 towards his bail, but that's all.
What have you heard?
Huh?
About the jail.
Why, do you need bail money for this afternoon? I knew there was a bunch of police cars gathering out there in the lot. But it's when all the men in the black suits start wandering around out there that I start getting more concerned about it than just police
Police around,
cars.
just call me Frank.
So you're not John
That's right.
when there's uniformed people around, okay.
I do have a question, and it's kind of, we probably already covered this, but when they say Ethernet, sometimes they mean different things. I mean, because Ethernet originally was like a bus, and they used
Mhm.
half duplex and the CA, CSMA, CA, right? But then with the new Ethernet, it's full duplex, and they don't use that, or is that, like, when I saw it said Ethernet 2, is that what?
So that you've gone, Ethernet has been upgraded over time from its original invention back in '69 or whenever it was, okay? The standard on it has been upgraded a number of times.
So, I mean, they show that when they talk about the LLC, and they're showing that Ethernet doesn't use that, but they mean the old Ethernet or something, right? I mean, Ethernet now uses,
Not because Ethernet's not going to be involved on the LLC.
yeah, I mean, that's kind of what it showed, and I didn't know if they meant like the way that Ethernet used to be. or
No,
the way
because
that it used-
Ethernet's not going to get it to the LLC because the LLC is getting to the software side. Ethernet's just concerned about on the wire, okay? Correct. And Ethernet's getting into the 802 standard, although they are showing that up there onto the LLC. But pretty much you're going to think on the Ethernet, most of the time you're looking at 802.3, which is from the Mac on down, and that the LLC is just the 802 portion of it.
So maybe it's the old Ethernet that used it, I don't know.
But you're down there on the bottom two layers in any of it. All right, the switches, it's going to keep a switch table, a MAC address table in there, which you'll also see called a switch table. That they've set it as a MAC address table here, but you'll see it called a switch table also. That's where it keeps MAC addresses of all the devices it knows, okay? That can be static entries, which means ones that we actually enter into it, but you're really not going to find that in there anymore on them. And dynamic entries, which is the ones the machine, the switch itself is going to keep putting in there or removing from it. The static ones, a human put them in and they stay there, okay? The dynamic ones are only in there for a time period. It defines the time period itself, and they disappear if they're not reused within a certain amount of time. Every time it sees something going to that MAC address or coming from that MAC address, it goes, okay, that MAC address I know is still active, which remember what I talked about those broadcasts a minute ago. That's one of the objects of those broadcasts is to remind the switch, I'm still here, so it doesn't drop it out of its table, which makes it quicker and easier for it to retrieve off of it. Everybody follow on that?
So when let's say we're all on the same switch, we're never looking at an IP address at all. It's just going to put out the destination MAC address and say, hey, I know where that is, and just forward it on to the next. Like if I were to.
No, it's going to look at both.
Yeah, you have to have it. Like the IP address, you have to have one.
From the frame viewpoint and the switch viewpoint, it only looks at the MAC addresses. Now, when it gets to your PC, it's actually looking at the packet, which is the IP address, okay? But as far as getting it ultimately there, it has to have the MAC address. But when you start out to send, you don't know what the MAC address is for the destination. So if you type in www.dwightwatt.com, your machine does not know what the MAC address of the server that my web page is sitting on. It does find the IP address, which is what we'll do in the next 2 chapters.
Well, let's just say we're sharing files or something.
In that case, you're going to put in on your machine to share the file, to get a file from his machine. You're going to type in his IP address. Your machine knows his MAC address because y'all are on the same network, so then it can send over to his machine, making the request for that file. But you didn't work with the MAC address. Actually, your machine worked with the MAC address, but your machine, because his machine had broadcast out saying, I'm here, it had its MAC and IP address on there, it added it, your machine added it to its switch MAC address table. And when you put in that IP address, it looked up that IP address, got the MAC address, and said, wait a minute, I know that machine. I don't have to send it out trying to get to the machine, not knowing where it is. I know that machine because it's on my network.
Of course, Windows does that. I mean,
That's all done in the background for you, okay? But in this class, you're learning the whole background.
Yeah.
Because if you're going on and being a Cisco person, you've got to do, you're setting all of that stuff up to make it do it. Now, if y'all aren't going on to be the networking people, you're getting a little deeper than what you ever use, but you know how it's doing it in the background. When something doesn't work right, you know what's going on. Because I realize not all of you are sitting in here as Cisco networking students. And the Microsoft ones do need to know that type of stuff, but you're not going to use it quite as much because you're working on the higher level. But if you know what's happening behind, the better you know it. And if you're not even in networking, though you're computer support, it still helps for you running the network and diagnosing problems with the machines of knowing what's actually going on behind the scenes. So to talk about learning it, I've already told you about how it learns those. Every time something comes across, it looks at the MAC address and says, is it in my table already? If it is, it marks that entry again, says, I just saw it again. So its time period starts all over again at that point before it's going to get removed. If it's not in the table, it adds it to the table because it says, I know where this came from. Okay? So it knows something about it. And then, so they walk you through on that and show you on how it keeps looking at those and adding those, and they spend a whole lot of time on that one with lots of drawings about how it looks at it each time and adds it to the tables. And then it continuously looks at the table also and says, are these aged out that they haven't been used? I don't know if they're still there or not. It removes it from the table if it doesn't know any longer. They could still be there. It just hasn't had any, it wasn't on its local network, so it's going, I don't know about it any longer. All right, questions on that? Because then I'm going to stop right here. So the next thing is switch forward key, which I started to touch on early in the class. But that'll take a little bit of time to talk about those two things. And then ARP is also mentioned, which we've really actually touched a tiny bit on already. Touched on already. I don't know where I came up with 2 alreadys from. And then we'll work with that accordingly. We'll do that on Thursday, talk about those 2 concepts. And that's going to get us through the switches, and then ARP is going to be the way to find out what is the MAC address. Now I say I've already touched a bit on that one to you along the way. All right, I will see you Thursday.